So I recently bought these two vintage heaters because it's winter. I wanted some warm heat, stop my wife complaining. So they're quite interesting because they span the change in the standard. BS 1945 was introduced in 1971, which puts a requirement on these guards. So in this version, I can put my finger through and I could potentially, if I was fool enough, touch these live wire wound resistors. But on this one, I can't get it through. And I've just looked up the standard. And the British standard finger, defined by the now withdrawn BS 3042, is 12 millimeters. So I've just measured 12 millimeters in diameter. It's got some dangly bits on it as well, but that 12 millimeters is the key parameter. So that's 9 millimeters, and this is obviously way bigger than that. It's probably about 20 millimeters. So this one probably comes from the 1960s, and this one probably from 1971 or afterwards. Of course, this one is obviously bigger, and heating elements are exactly 12 inches between centres, and I think this one is 9.25. Anyway, I thought we'd have a look inside the bigger one. It's more interesting and it's better made. But the reason for doing this video is one of the elements that came with this didn't work. So through the magic of eBay, I bought a selection of replacements, and interestingly they have different resistances, which actually has quite an impact on the power consumption. Or does it? We'll see. I'm going to do some experiments later. Just one thing to mention before I get on analyse the bigger heater. I changed, among other things cleaning it up, I changed the flex on it. So the original flex that came with it, I can focus the camera on this, had this, I think it's either aluminium or plated steel wire. It's nice and thick, as you'd expect for a potentially 3 kilowatt device. And to be honest, the insulation doesn't appear to have broken down at all. But I've measured them. This is about 3 meters long, and it's about half an ohm in each conductor. So if you're drawing close to 13 amps, that's potentially quite a lot of power. So I've changed it for some modern industrial flex, really. It's 2.5 mil copper. And I haven't measured the resistance, but it should be about 0.1 ohms for the same length. So that's better. Anyway, without further ado, let's have a look inside. So this is the smaller one, and on the back there is a label here, which very nicely gave me the information about the standard. I presume BSS means British Safety Standard, not just British Standard. And this one is 1.5 kilowatts. So this might have been made for export. It's pretty cheaply made. Very thin metal. But the other one, as we shall see, is probably only for the UK and Irish markets, because I think they're the only countries in Europe that have supplies that can deliver 3 kilowatts of standard. So here we are. Here's the specification tag. The font certainly looks like the 1960s. The metal is quite a nice thick gauge. I have cleaned this up, but yeah. Right, I'll take the back off and we'll have a look inside. So this is the inside of the bigger unit. There's some corrosion here, which when I got it, there was lots of dust and grime there, which I cleaned off, but everything else hasn't corroded, so I can only assume that there was something in the dust that caused that effect. Anyway, this is the new flex. So there are a few things to note here. One is quite clever strain relief, which I've seen on other products, but these days you tend to get just a cheap plastic clip. Anyway, there's the threaded insert there, and then this goes through the metal case and holds the strain relief to the case, and then there's a grommet. I've changed the grommet, but there's a grommet there to stop it rubbing. So a few little things that are quite interesting. There are no crimps here. The wire is just held down by these clamps, so you don't want to break the strands of the cable when you do it up. And then the internal conductors That one's not corroded, and that's copper, I think. I don't know what these are, but so the way it works is the neutral is commoned up to all three heating elements, and then the live is the top live bar is always on, so you've got to have one bar if it's plugged in, and then the other two elements are switched in with these rather nice switches. So in the picture here, we've got one open and one closed. So if I see, there's quite a nice big clearance. I mean, it's AC, so we shouldn't get an enormous arc forming, or if it does, it should terminate very quickly. But yeah, that's quite satisfying. And then they're all screwed on. They're all screwed on here. It's very nice construction, and then this separator here keeps the well, I guess you call them kind of wires. We're going to call conductors separate, and stops them from touching the parabolic reflector. The camera right. When I was cleaning this outside, the heat from the sun on a January day was quite warm, reflected from this, which I thought was quite impressive. That's quite thin. This looks about 0.6, 0.7 mil. Yeah, so there we are. Fairly simple construction. Although I don't think it's anything particularly cheap and nasty. There's nothing in here that smacks of value engineering. And then the front panel, if I can get this focus this camera, the front panel has got this grill which comes off, and that's how we change the elements. So in a minute we're going to investigate these elements. I'll just put it back together first. I'm just going to open it now and take out the top element, because that's the one that's broken. Even this mechanism is quite nice. It's easy to maintain. Just two screws holding it at the bottom, and then it just flexes out of these holes. So I can scratch the paint. So these two work. Interestingly, this one was quite filthy. I cleaned it in the ultrasonic bath, and it came up a lot better, and it still works. But this top one, which looks visually intact, doesn't work. So we're going to inspect that too. So this is quite a nice little feature. It's got these little brackets here, which you rotate up. So after you've undone these thumb screws, finger screws, you have to move this up before you take it out. The slots face upwards, and I think that's to stop it, if it were to work loose when it was being moved, to stop it falling out and breaking the ceramic that's in here. Okay, so I'm going to measure the resistance of these heating elements. Because this appliance is going to draw close to 3 kilowatts, we want to be a little bit careful that we don't draw the full 3 kilowatts, because that'll blow the fuse. And in the past, I've seen fake fuses blacken the plug. Nowadays, appliances don't tend to draw the full 13 amps, except momentarily. So we're going to measure the resistance of these elements. And that one is 52.7, which I've just worked out will correspond, that's 52.7, that's quite accurate, correspond to 1092 watts. Now, my theory is that they'll heat up, the resistance will increase, and therefore they won't draw as much as a kilowatt. They'll draw slightly less than a kilowatt, so when we've got 3. But what I found interesting is, which I'll show you now, is that the elements that I bought, the new old stock elements, had varying different temperatures, and they're not marked on the box. So let's measure the temperatures of those. So these are the heating elements that I ordered. They're in generic boxes, and all it says is the length. Nobody's written the watts on there. I don't know when these were made, but it's interesting that they've got an appropriate disclaimer on their side. So they're obviously made by somebody who is making them for all sorts of manufacturers. Electro Replacement Limited. I wonder if they're still in business. Anyway, I'm going to measure the resistance of these now. This is what a new clean one looks like around its, focus the camera, around its ceramic. Let me get focus. Yeah. Anyway, so let's measure it and we'll see. So the old ones are 52.7 and this one is 59, so that'd be probably okay to put in the heater. And I'll measure the others, because when I measured it before when they arrived, there was one that was quite low. Here's another one. Yeah, so that's 48 ohms. So unless that rapidly increases, that'll be using quite a lot more than a kilowatt at 240. And what about this one? $48 again. And finally, interestingly, on some of them, the end of the thing is a little bit rusty. Again, that's 60 ohms. So we're going to put one of these in, not one of the 48 ohms one, but I'll do some math now and work out what we see. And then we're going to look at the power consumption of the device and see if it drops when they get hot, which will be interesting. So I've got it reassembled, and then I'm going to measure the resistance before we turn it on. So we've got 59 ohms with both of the switches off. We switch one on, switching another element into parallel, and we get to 28 ohms. And we switch it on again, and they're all three in parallel now, so we're getting 18.4 ohms, which, using V squared over R, with 240 as the voltage, you get 3.1 kilowatts. So if this isn't going to blow the fuse, we can only assume that the temperature is going to cause the heating elements to rise in resistance. So we'll do some other measurements now. So I've just turned it on for the first time with this new bar. Hope it's not going to be too smoky in here. It'll take about a minute normally to get to visibly radiant heat. And then I'm going to measure the resistance across the plug again. But I'm going to do it with one bar for now, in case the resistance doesn't fall. So it was 59 ohms, just the top element on. And I'll speed this up while it heats up. So there we are. We're about full radiant heat. So now what I'm going to do is I'm going to unplug it and we're going to measure the resistance. Remembering, of course, that it was 59 ohms to begin with. Now, hopefully, this is going to work as a 3 kilowatt heater, or approximately 3 kilowatts. That should have fallen quite considerably. Sorry, that should have increased considerably so that the current will fall. And, oh yes, the resistance has improved, right, increased to 64 ohms. So we can work out how many kilowatts that we're going to be. So that's only 900 watts. So having got hot, 900 watts. So that poses an interesting question though, doesn't it? Because if you plug this in straight away and that temperature doesn't increase very rapidly, you're potentially going to blow the fuse. So you kind of need a soft start. I don't think was really a thing in the 60s. Maybe the fuses were more manly then. But yeah, I won't be turning it on with all three straight away. We'll have to turn on one, then two, then three, or perhaps two and then the last one on at all. So here's a final shot of it drawing nearly 13 amps. I don't actually know. I haven't got a power meter that will measure more than 10 amps. But yeah, that's a three bar electric heater. It's very, very effective. It's very nice. Makes me slightly nervous when the dog walks around in front of it, wagging her tail. And I certainly wouldn't operate it near any small children or anybody who might be inclined to touch the glowy red hot thing with any part of their anatomy. But nowadays it's relatively safe to operate them compared to in the 60s, because everyone's got RCD, or what the Americans call ground fault interrupters, to protect them. So if you were to touch it, you'd probably get more damage from the finger burn than the electric shock, assuming it's on an RCD protected circuit, which most domestic installations are these days.